Welcome to the Chemistry 11 review for the Chemistry 12 course. We're going to start by reviewing how to convert from mass to moles. So if you have a question such as, if you had 16.7 grams of sodium hydroxide, convert this to moles. So the first thing we have to do is find the molar mass of sodium hydroxide. So that's how many grams are in 1 mole of sodium hydroxide. So we have to go to the periodic table and we have to look up sodium, which is 23.0 on the left side. And over on the right side, oxygen, which is 16.0. And then hydrogen on the top left, which is 1.0. So we have to add those three together. So 1 sodium is 23.0, 1 oxygen is 16.0, and 1 hydrogen is 1.0. Remember for sig figs, when you're adding, it goes by place value. And on the periodic table that you're going to use in Chem 12, every atomic mass is given to the 10th column. So your molar masses that you calculate are always going to be the 10th. So 23 plus 16 plus 1 is 40, but it's going to be 40.0, and that's grams per mole. That's how many grams of sodium hydroxide are in 1 mole of sodium hydroxide. Now you can write molar mass two ways. You can write it like this when you put it into the table, or you can write it like this. Whenever you do a conversion, you always start with the given value, 16.7 grams of NaOH. Now, because we have grams on the top, in order to cancel that unit, we need grams on the bottom in the next step. So we look here and here, which one has grams on the bottom? It's the second one. So we're going to write it in like this. The gram units will cancel. You'll be left with mole units. So to get the answer, it's 16.7 divided by 40. We got 3 sig figs here, 3 sig figs here. So our answer will have 3 sig figs, and the answer is 0.418 moles. It makes sense if you think about it, because if 1 mole is 40 grams and we only have 16.7 grams, that's less than half of 40. So our moles should be a little less than 0.5, and that's exactly what we see. So on the bottom where it says, how do you convert mass to moles? If we wanted to summarize this into one thing, we would say divide by the molar mass, because that's exactly what we did here. So let's write that into our notes. And we'll move on. Now we're going to do the opposite. Oh, sorry. We'll move it one more. There we go. Now we're going to do the opposite, converting moles to mass. So what if we start with moles of something and we want to get the mass of that thing? Well, similar idea. The first thing you need is the molar mass. So the molar mass of HCN, we have 1 H, 1 C, and 1 N. So if we go to our periodic table and look up H, it's 1.0. Look up C, it's 12.0. And N is 14.0. So we're going to add an H, a C, and an N. And that equals 27. But because these were off the periodic table, we have our sig figs to the 10th. So it's 27 grams per mole. Now if I wrote that as a fraction, it would either be like this or like this. So when I convert 0.756 moles to grams, this is my starting value, so it's going to go on the upper left hand part of the table. And since I have moles on the top here, I need moles on the bottom in the next step in order to cancel my units. So I look up here, and this is the guy I want, because it has moles on the bottom. So I write it into my table. The moles cancel. So to get my answer, it's going to be 0.756 times 27.0. I have 3 sig figs here and 3 sig figs here. So my answer is going to have 3 sig figs, and the answer is 20.4 grams. If you think about it, it makes sense. If 1 mole is 27 grams, we have about 3/4 of a mole. And so our answer is going to be about 3/4 of 27. And so we get 20.4. Just to summarize, how do you convert moles to mass? You multiply by the molar mass. Moving on, we're going to do an example of stoichiometry. Stoichiometry is an entire unit you did in Chem 11, and it's all about finding how much of something you have if you have data on another substance in the chemical reaction. So let's look at this question. What mass of copper metal is produced if 14.5 grams of lithium metal reacts? So 14.5 grams of lithium reacts. How much copper metal can we make from that? So it says, what should you do first? Now here's the key to stoichiometry. The first thing you want to do is you always want to get to moles. Get to moles. So we have 14.5 grams of lithium. We want to get that to moles of lithium. Okay, and then it says, when can you transfer from one substance to another? When you have moles. And that's, of course, why we want to get to moles. Let's take a look at the stoichiometry map, and then we'll come back to this. Here's a stoichiometry map. Here is your starting substance, the substance you're given information on. Sometimes you're given information on the mass of the substance, like we are in our particular questions. Sometimes you might be given the amount of molecules, or maybe the volume if it's a gas. So if that's the case, your first step is to get to moles of that substance. However, sometimes in a question, you're just given moles right off the bat, and that's great. That means you're in a position right off the bat to go over the mole bridge, meaning use the mole ratio from the balanced equation to get to moles of substance 2, the one you're trying to find out more about. Once you have moles of substance 2, then you can do one more step and you can get the mass of that substance, the amount of molecules, or if it's a gas, you can find the volume of that substance. So going back to our question, we're starting with a mass of lithium, and we're being asked to find a mass of copper. So we're starting here with mass of lithium, and we're being asked to find the mass of copper. What we're going to do is count the jumps. 1 jump, 2 jumps, 3 jumps. Because there's 3 jumps on the map, that means we're going to need a 3-step table, which you already have set up. And how you make a 3-step table is you draw 3 vertical lines, as I've already done, and then a horizontal line all the way through, and you have a 3-step table. So the first step is to take our starting value, which is 14.5 grams of lithium, and we want to get to moles of lithium. So to get to moles of lithium, we need the molar mass of lithium. And on the left side there, you can see that the molar mass of lithium is 6.9 grams per mole. Because I have grams on top here, I want 6.9 grams on the bottom and 1 mole on the top. Because a molar mass is always how many grams are in 1 mole of a substance. So at this point, I'm in moles of lithium if I do this calculation. So on my map, I am now here. So my next step is to go from moles of lithium to moles of copper. So this is the key step in the entire equation. So that's going to be right here, and I'm going to use my mole ratio from the balanced equation. So first off, I look up at the equation, I make sure it's balanced, which it already is, and then I look at the coefficients for lithium and copper, and of course there's a 1 here. So my ratio is 1 mole of copper for every 2 moles of lithium, Or I could write it the other way, 2 moles of lithium for every 1 mole of copper. What I have to do is look down at my equation, and on the top here, on the last step, I have moles of lithium. That means I need moles of lithium on the bottom in the next step. So it's going to be this form of the equation. So 2 moles of lithium on the bottom, 1 mole of copper on the top. Notice how moles of lithium cancels with moles of lithium. And if I go back to the first step, grams of lithium cancel with grams of lithium. So now, after step 2, I'm in moles of copper. So I am now here on my table, on my map, sorry. So my last step is to go from moles of copper to mass of copper. Now, to go from moles of copper to mass of copper, I am going to need the molar mass of copper. So I go to my periodic table, and in the middle you can see copper, number 29, Cu. It has a molar mass of 63.5. And so my molar mass of copper is 63.5. So I could write it like that in my table, or I could write it like that in my table. So what I got to do is look at the previous step. I have moles on top, so that means I want it in this form. So I got moles on the bottom now here. And you can see that moles of copper cancel with moles of copper. So I've done my 3 steps, and now I'm ready to calculate my answer. Any number on top is a multiply. Any number on the bottom is a divide. And you can, of course, ignore the ones. So it's going to be 14.5 divided by 6.9 divided by 2 times 63.5. I'm also going to look at my sig figs. I have 3, 2. Here you don't have to worry about sig figs when you use the coefficients. And here I have 3. So I am limited to the least amount because this is all multiplying and dividing. So I only get 2 sig figs in my answer. So when I work this out, 14.5 divided by 6.9 divided by 2 times 63.5, my answer is 6.7 grams of copper. So if 14.5 grams of lithium react in this reaction, I'm going to produce 6.7 grams of copper. Here's the answer, and it looks a little bit cleaner, so I'll give you a chance to have a quick look at it. There it is. And then moving on in your notes, it says to draw the mole map for stoichiometry. You might want to try that, and then you could check the answer later using the answer key on the web page. And then there's some practice stoichiometry questions, and I will show you the answers to those if you want to try them, and then you can play the video again to check your answers. So there's the answer to number 1A. You can also get these answers from the web page. There's the answer to 1B. And there's the answer to 2. For number 2, you had to first make a balanced chemical equation, which you should hopefully be able to do from Chem 11. One last thing to show you, if you go to my web page and you go to the Chemistry 11 page at the top and you hit this link here, Chem 11 Animations, and then scroll down until you get to stoichiometry, you will see that there are quite a few tutorials and animations from my Chem 11 page here that can help you with stoichiometry. So there's a couple of videos that might be very helpful. So if you're still having trouble, I would recommend that you do that. Thanks for listening.